Okay, so in this lesson, lesson 2, we're going to talk about prime factorization. We're going to talk about prime factorization, and then we're going to move on and talk about a lot of the uses of prime factorization. And again, it's just extending some of the things we learned about last lessons, which are prime numbers and factors. So what a prime factorization is it's a representation. When we say representation, we're meaning that it's something that is the same as something else, right? When you represent something, you're using something to mean something else. And so it's a representation of a number as a product of prime numbers. So when you do a prime factorization, what you've done is you've taken a number and rewritten that number, usually an integer is what we're talking about here, as a bunch of factors, and all of those factors are prime. So it's different than factoring a number, right? When we look at, let's say, 24, 2 times 12 are factors of 24, but they aren't prime factors of 24. So what we're looking for now is what are prime factors of 24. So when I say find the prime factorization of 84, there are two main ways that we do this. You probably know, especially this first way, you've probably done this before, but let's just review it. The first way is a factor tree. And what we do there is it's just a visual way to show this repeated process of factoring things. And what you look for is you look for some number that you know goes into 84. I usually try to find two bigger numbers, right? I know 2 goes into 84. Hopefully everybody knows that because it's an even number. But I also know that 4 goes into it as well. And so I can say, well, 4 goes into 84. And so that's first part of my tree, because 4 times something is going to give me 84. And what it needs to be multiplied by is 21. So right there, 4 times 24 is or 21 is a representation of 84. But they're not prime numbers. So we have to keep factoring using this tree until we get to all prime numbers. So we look at 4 first. If I look at 4, well, 4 factors to 2 times 2. Now we have prime numbers. 2 and 2 are both prime numbers, so that's really good. So we're done there, because we're always finished whenever we get to prime numbers. I need to look at 21. 21's not prime. Hopefully you can very easily see that 3 and 7 go into 21. 3 and 7 are prime numbers. So we now have a product of prime numbers, 2 times 2 times 3 times 7, that equal 84. The way that we write it is, well, there were 2 2's, so we say 2 squared times 3, and that's like 3 to the first, times 7. So the prime factorization of 84 is 2 squared times 3 times 7. Another method that I want to show you is it's kind of like a reverse division is the way that we do it. And so we start with 84, and then we put in a upside down division bar, and we ask ourselves the question, what prime number goes into 84? Well, now this is where 2 does what we want to start with. I know 2 goes into 84. And 2 goes into 84 42 times. And again, this is prime division, so you're only dividing by prime numbers. So this is a totally separate way. If you don't like this way, you can use the factor tree, but some people like this way because it's often done quicker than a factor tree. So we know that 2 goes into 42, so that there's 21 left over. Well, 2 doesn't go into 21, so I go to the next prime number, which is 3. 3 does go into 21, and that leaves us 7. Because once this number here is a prime number, we know we're done. So the prime factorization is 2 times 2 times 3 times 7, which is exactly what we got before. So 2 squared times 3 times 7. So those are the two different methods that we're going to use. You can choose whichever one you like better. For my example 2 here for 120, it would be good right now for you to pause this video and to try to do this problem on your own. I'm going to use the factor tree. So when I look at 120, to me, there's a couple different obvious ones, but I know 2 times 6 is 120, so I could say, right, I don't know, 6 times 20 would give me 120. And so then I look at 6, and I can factor that to 3 times 2. Well, those are both prime numbers, so I'm done with those two branches of the tree. 20 is not prime, so I look at 5 times 4. 5 is prime, so I'm done with that branch. The only branch I have left to look at is 4. 2 times 2 is 4. So now I've got it as a product of all prime numbers. And notice I need to make sure to designate them somehow so you remember which numbers were the ends of the branches of this tree. In this case, it's going to be 3 2s, so 2 to the third times 3 times 5. And so 2 to the third times 3 times 5 is the prime factorization of 120. The next one we're going to look at is 1260. This is a little bit bigger. Again, pause the video. Try to do this problem on your own. 1260, well, I'm going to use the reverse division this time. It's a big number, so it might take a little bit. Again, the good thing that we love even numbers, because whenever we have an even number, we can divide by 2. This isn't real easy to divide, but if you have to do it over the side, that's fine. But some of you might be able to recognize that 1200 divided by 2 is 600, and 60 divided by 2 is 30. So when you divide this by 2, you get 630. Divide this by 2. Well, 2 goes into 630. Well, half of 630 is 315. 2 no longer goes into that. So we look at 3. Now the question is, does 3 go into 315? Well, the answer is yes. The reason I know that is because the sum of the digits of 315 is a multiple of 3, right? 3 plus 1 plus 5 is 9. So 315, if we divide into 3, we're going to get, right, 105. And so when I divide it in, divide 315 by 3, I get 105. It's still divisible by 3 because 1 plus 0 plus 5 is 6. That's going to be 35. And then 35 we know is a very common, and that's 5 times 7. This is a prime number, so we know we're done. So you get 2 2s, 2 squared, 3 squared times 5 times 7. That is a representation of 1260 using only prime numbers, as we call it the prime factorization.